Hello everyone. Our lesson today is lesson 1 on unit 2, which is linear inequalities. In this lesson, we will solve linear inequalities graphically. We get the solution set graphically. Okay, first we want to remember the properties of the inequality. If we have A, B and C belongs to R, then if A less than or equal B, so if we added number like C to the both side, the inequality will be as it is. So A plus C less than or equal B plus C, and here C may be positive or negative. Okay, the inequality doesn't change. Number 2, A less than or equal B. Here A times C, we multiplied the number or we divided the number. If the number C here is positive, so that the sign of the inequality will be as it is. Here we have less than or equal, so it will be less than or equal. Number 3, if we have here C is negative, so we will change the sign. So here we have A less than or equal B. It will be greater than or equal. Why? Because C here is negative, less than 0. So if we multiplied or divided by negative number, we change the sign of the inequality. Here we will solve, as we said, inequalities of first degree of one variable graphically. Here we have inequality 3x plus 10 greater than 1. We want to get the solution set in R and in R times R squared. First, we get the solution set in R. So here we have the inequality 3x plus 10 greater than 1. First, remove 10 in the other side by opposite sign, which is negative 10. So we have here 3x greater than 1 minus 10. So 3x here greater than negative 9. We want to get x, so move here 3 in the opposite side by divided. Here 3 positive, so the sign it will be as it is. So x here will be greater than negative 9 over 3, which is x greater than negative 3. Okay, we want to get here x greater than negative 3. We want to represent it, the substitution set in R and the substitution set in R times R. First, in R. In R, we studied in second prep by the interval. So here the solution set is all the real numbers which is greater than negative 3. So we represent it by number line. So first write number line. Here we have here 0, 1, 2, 3. Here is the positive part, and here negative 1, negative 2, negative 3, negative 4, and so on. Okay, so we have here x greater than negative 3. Greater than negative 3, which is the part of the number line on the right of negative 3. So here we have negative 3, and here we write circle unclosed. Why? Because we don't have here equal. If we have greater than or equal, we shaded this circle. Okay, so here we have unclosed. Greater than negative 3, as we said, the right part of the number line here. All the number here. Okay, and also as we said here negative 3 unclosed, it means here negative 3 not belongs to the inequality. Okay, here in R, number 2 in R times R, or in R squared. Number 2 here in R times R, which is R squared. R squared here, it means we have the square lattice. Here we have x and x dash. Here we have y and y dash. Okay, as we said here, x greater than negative 3, greater than not equal. So we write a straight line dashed on x equals negative 3. Here dashed like this. Here we have straight line okay. Here we have x equal, sorry, here we have x equal -3, okay. So here first write a straight line, x equals -3, and we draw it dashed because the points not contains the solution set. As we said here, x greater than -3, not equal, okay. And the solution set here will be all this part. The solution set will be all this part. We shaded this in the example, okay. Here we have all of this are x greater than -3 in the substitution set r squared, okay. All of this are x greater than -3. Okay, we have another example. Number 2. Show graphically the solution set of the inequality 5x minus 7 less than or equal to x minus 1 in R. Here we have 2x in the two sides, so collect x in one side. So here we have, since 5x minus 7 less than or equal to x minus 1, so remove 2x in the other side by -2x. So 5x minus 2x, and remove -7 in the other, less than or equal. Here we have -1, -7, it will be +7. Here 5x minus 2x, it will be 3x, less than or equal. -1 plus 7, it will be 6. Remove 3 in the other side by divided. So here we have x less than or equal 6 divided 3, which is x less than or equal to, okay. Here we want to get the substitution set in R. Here in R, it means all the real numbers less than or equal to. So here we have an interval, okay. So we write the number line here. Here we have 0, 1, 2, -1, -2, -3. Here we have x less than or equal to, less than or equal, so we shaded the circle because we have equal. Less than, it means the left part of the number 2, okay. So the solution set here represented on the number line. We have another example. Show the inequality of this. Show graphically the inequality x minus 1 less than or equal 4x plus 5 less than x plus 17. Here we have x in the three sides, okay. First, remove the number here in the middle. Remove in the right side and the left side, okay. So here we have x minus 1, remove 5, it will be -5, less than or equal 4x less than x plus 17 minus 5, okay. First, remove the number in the middle, okay. So x -1 minus 5, it will be -6, less than or equal 4x less than x. 17 minus 5, it will be 12, +12, okay. So here we have x minus 6 less than or equal 4x less than x plus 12. We cancelled here x with x, so we get -6 less than or equal. Here we cancelled, and we cancelled here 4x, we get 1x, so it will be 3x, okay. So we get here 1x, 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 it will be cancelled. 1x from the middle, it will be 3x. 1x here, it will cancelled. And here we have 12. Okay, here we have 3x. So remove 3 in the other side by divided. So -6 divided 3. Here x, here 12 divided 3. So here we have x greater than or equal negative 2 and less than 4, represented in the number line. So we have here negative 2, negative 1, 0, 1, 2, 3, 4. It means here negative 2 closed because we have here or equal, and 4 unclosed, and the solution set will be all these parts. Here the solution set will be closed negative 2 and 4 will be unclosed, will be open. Okay, here also we write the solution set will be here x less than or equal to, start from the smallest. Here negative infinity is the smallest, open, and 2 closed. Here the solution set here will be here negative 3 open and infinity open. Okay, the last one. Here in the previous example we have the coefficient of x here 1 and the coefficient of x here 1. Okay, so we cancelled and we cancel 1x from the middle. Here we have the coefficient here 2 and the coefficient here 1, not equals. So we divide the page. First we get 2x minus 2 less than or equal 3x minus 1, and divide the page and get 3x minus 1 less than x plus 5. Okay, so we have here two inequalities. If we get the coefficient here not equal the coefficient here, we divide the page and get the first inequality and second inequality. Okay, here 2x minus 2 less than or equal 3x minus 1. So first remove 3 in the other side. So here 2x minus 3x less than or equal here negative 1, negative 2, it will be positive 2. So here 2 minus 3, it will be negative x less than or equal 1. So here we have negative x less than or equal 1. We want to get x positive. So here we have negative 1. So remove negative 1 in the other by divided. So here divided by negative 1. As we said, divided by negative 1 or multiply by negative 1, we change the sign. Here less than or equal, it will be greater than or equal. Don't forget. Okay? So here the solution set here, first get x greater than or equal negative 1. So the solution set here will be negative 1 closed because we have equal and infinity. Okay, and also we will represent it on the number line. Okay, here the second one, 3x minus 1 less than x plus 5. First remove x in the other side by negative x, and also remove negative 1, it will be positive 1. 3x minus x, it will be 2x less than 6 divided by 2. So x here less than 6 divided 2, which is x less than 3. So here the solution set here, all the numbers less than 3. It will be start from the smallest. So here the smallest is negative infinity, and 3 open because we don't have here equal. Here the solution set will be negative 1 and infinity intersection negative infinity and 3. So the solution set here will be negative 1 infinity intersection from negative infinity to 3. Okay, represent in the number line. Here we have negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Here from 3 will be open, okay, and negative infinity. And here from negative 1 closed to infinity. So the intersection here will be this part from negative 1 closed to 3 open. So here the solution set can be right as negative 1 closed to 3 open. Okay? Thank you.